Martha, is that you?
It's me. Can you hear
Oh,
me?
good. Yes, I see Martha has logged in. Oh, there she is.
I'm here too.
All right, do this thing. Rachel mentioned doing another Databricks soon. I don't know if what your availability is.
Another Databricks class
Webinar.
for on a
Oh,
different topic,
probably.
like deep learning or something.
Yeah, that would be cool. I could send you some open dates that we have.
Okay,
Cool. You
fine.
don't have anything on Data Factory, do you?
I can. I'm pretty good at it.
Hmm.
It's a lot different. In fact, I think you know, I think we already have the courseware for it too.
Oh yeah, because Ron's looking for it for a class on Monday.
I don't think we can get it together by then, but
Yeah. I don't know when it is, Martha. Is it towards the end of the class though? Like Thursday?
The class ends on Thursday, so I think it's Wednesday.
Yeah.
But we have lots of requests for it. Like if you happen to have some material.
yeah, I know we do. I just have to talk to the guys at Reliant Zoiner about it.
Mm,
Um, the
very cool.
material we've delivered several times, but yeah, we've never sold it. Right? We've never, like Reliance has never let someone else use it.
Okay.
So I don't even think I have a thought on how to do that yet. But they know they need to. I just talked to Zoiner yesterday about it.
Okay. That would be awesome because you have a plethora of talent to pull from.
And we have a lot of material, like on Azure SQL Data Warehouse and Azure SQL Database Managed Instance, and on the Azure Databricks, a ton of material.
Oh my gosh, we need all that. So yeah, let us know. I'll kind of loop back around with you on that. Okay,
Cool.
I am going to go silent for you to start.
Is it
Thanks,
11 right
I.
now?
It's like a minute till.
And how, and we have like, how many attendees are there?
Well, right now, let me see. It says 0 at the moment, but they don't filter in until you hit the start button generally.
Okay,
So
cool.
you could hit the start button and then just be kind of quiet for, 20 seconds or something and watch them filter in. Okay, now it says they're on hold. Now they're starting to fill in because it's almost 11. Okay, now they're starting to come in. Can you see them
Yeah, 18.
so far? Yeah, it'll just keep, it's like it houses them.
Hey Kim, how many end up registering?
263?
Oh, nice.
Yeah. All right, I'm going to mute. Thanks, Ike.
Yep, good luck. Thanks. Hey, this is Ike Ellis, and you are here for Azure Databricks is easier than you think. And I can see a whole bunch of people signing in right now. And I can just see the numbers kind of climbing, 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 climbing. So I'm a little reluctant to get into the heart of the conversation until the numbers calm down a little bit. But in the meantime, what we can do is talk about some of the slides that Wintellect likes us to cover at the beginning, just so that you understand Wintellect's offerings. Wintellect is a consulting company that does consulting and instructor-led training. They do training, both public courses and corporate training, and they also do on-demand web-based training where you can buy an on-demand subscription and see a lot of our training material at your leisure and in your pajamas. Wintellect has a very good relationship with Microsoft, and a lot of their training and consulting is geared around the Microsoft ecosystem related to Azure and SQL Server and .NET and Xamarin and a lot of other things. You can go on our website to find out more about the training. The Wintellect consultants and trainers that are available to you have written books. A lot of them are MVPs. Including me, actually. I'm an MVP and I've written several books. I've got a new book coming out this year on Power BI. It's an MVP a co-author initiative where about 20 Power BI MVPs got together and each wrote a chapter of a book, and all the proceeds are going to charity. So it's a pretty neat initiative coming out. And then we have an offer. If you've been to this webinar and you want to attend a public course, you can get a discount on it. And so check it out. That might be interesting to you. And with that, it looks like the number of logins is stabilized, maybe a little bit. No, it looks like it's still climbing. But I think we can start talking about the intent behind this webinar. You and I are together for about an hour, and I want to make good use of that time. And my goal behind this webinar is so that you feel comfortable with Spark and you feel like Spark is not that difficult. Often if you've had like a relational database background or a software development background, massive parallel processing systems like Hadoop and Redshift and Spark can feel really a little bit scary and daunting to learn. But really it's not. It shouldn't be that scary and it shouldn't be that daunting. And you can use Spark for projects that you're using right now, that you're implementing right now, and you can learn it. You can learn it specifically. It's just not something that's insurmountable. So our goal for this session is so that you feel comfortable with it, you feel like there's an easy way of learning it, and you feel like you understand when to use it and what problems it addresses. But let's talk about the problem just right now that you're probably having. And that is when you do ETL work, meaning you're moving data, you're taking data from a source and you're moving it over to a destination. If you've ever said any of these things like, oh, the data load takes 4 hours and when it fails, we have to start the whole thing over and it's really hard. Or the data load takes 4 hours and when it fails, sometimes the workers don't get to work with the data until 11 a.m. or noon. Or sometimes the data loads really fast and we can get it done in an hour, and sometimes it doesn't end and it takes like 8 hours to finish, right? Or the ETL processes that we have, SSIS is really fragile, meaning it runs and then when it fails, it takes way too long for us to figure out why it failed. And when we do discover it, we don't have a really good method of like starting where we left off, right? All of those complaints are because ETL in general, when it's single threaded or single server, it just doesn't scale very well. And so if you want ETL to finish in a reasonable amount of time, and if you want it to be less fragile, then you need an MPP system. You need something where you're scaling your nodes out on multiple servers and where you're partitioning your data so that portions of your data can succeed while one portion fails, and then when you have to rerun it, the rerunning of the smaller portion of your data takes 10 minutes or 15 minutes or a half hour. It doesn't take 4 hours, right? So if you have those problems, then Spark is the answer to those problems. And the industry has kind of agreed with that statement, where Spark is being used kind of in more and more organizations and across more and more departments to solve those particular problems. Now, I can't promise you that at the end of this hour, you will know how to use Spark to solve that problem. What I can promise you is at the end of this hour, you'll feel more comfortable learning Spark and doing what you have to do in the future so that you feel like you're up to the challenge. And I'll give you a path at the end. If you guys stick around to the end, I'll show you kind of the easiest way to learn Spark. Obviously, I'm going to say, take a Wintellect class, but if the Wintellect class isn't in your future, then I'll tell you what books to read and where to go for more education if you're just trying to learn it on your own. So what is Spark? Well, before I explain what Spark is, I think we should talk about what Hadoop is just for a second. So I'm going to switch off of the slides and I'm just going to go to MS Paint. And I apologize if you can hear my dog drinking in the background. He always drinks at the worst time. So the most popular aspect of Hadoop is HDFS. And what HDFS stands for is Hadoop Distributed File System. And let's talk about file system first, because I think to explain what the file system is, we just need to kind of level set for just a minute. So if we had a hard drive here and we had a file, let's just say we had a 100 meg file here, right? And we saved part of the file here and part of the file here and part of the file here on this hard drive. Before that hard drive, we would have a directory entry table. And this could be NTFS or it could be FAT or whatever file system that we have. That directory entry table would say, like, if you were looking for customers.csv and it's 100 megs, part of it is stored here and part of it is stored here and part of it is stored here. So if you were a user and you said, hey, read customers.csv, you would read out of the NTFS directory entry table or whatever, and it would find this data and it would hand that data back to you, the user, right? So that's easy. You guys know this. You probably have worked with these things for a long time. So what is HDFS? Well, if that file isn't 100 megs, but instead it's 100 terabytes, well, now we have a file that is too large for any single hard disk and potentially too large for any single server. So imagine we have different servers here, and now each one of those servers has a hard disk, right? Now we need a directory entry table that spans multiple servers and multiple hard disks, and that directory entry table sits on what's called a name node or a primary. So if you have 100 terabytes and you store, 50 terabytes here and 10 terabytes here and a bunch of terabytes there, and a user says, hey, I want to read customer.csv, and it's distributed on multiple servers, it goes to the name node, which is a server, right? And that name node says, oh, I know where that file is. Part of it is on that server, and part of it is on that server, and part of it is on that server, and it collects those things, and then it hands that back to the user. And this is like the most popular aspect of Hadoop, this Hadoop distributed file system, where we have files that are located on multiple servers and multiple drives. So that brings us to what is Spark. So what Spark does is we have multiple servers here, just like Hadoop's HDFS, and we have disks, right, in HDFS, but we also have RAM. We also have memory. And Spark has this primary node that they call the driver. And the user says, I've got a bunch of data that I want to read out of memory, not out of the hard disk. I want to read it out of RAM, right? And Spark says, oh, well, we can load this CSV, customers.csv. We can put part of it in RAM. So we're going to load it off of HDFS into RAM. And then we're going to treat this RAM as if it's collectively one set of memory for you. And so as the developer, you have an object, right? var df equals something, 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 right? df is pointing to a distributed version of RAM across multiple nodes. And why is that valuable? Well, you could probably guess. RAM is about 1,000 times faster than the hard disk is. And so if we can treat RAM across multiple nodes as if it's one entity and we can hydrate it as one variable and work with it as one variable, we are going to create an environment that is very, very fast. And that speed gives us a specific benefit. If we go back to the Hadoop benefit, so we'll go back to our Hadoop example, right? Because HDFS is primarily hard disk, another thing that Hadoop does is when we have work that we want to do on our data, each one of these machines has a CPU. So this CPU, when we have a job to do, a bunch of code that we're writing, and we're running it on the CPU, we're trying to keep the code that we're running on the CPU close to the data. And Hadoop does that by doing something called data locality. So Because Hadoop is doing this all the time, it's very disk bound. Hadoop likes to work with just that section of the disk and read and write off the disk, right? Spark does the same thing, but it does its work close to the area that it's working in memory. So what's happening in Hadoop is, because Hadoop is so disk bound, Hadoop is really good when there's batch jobs. Like when you say, hey, make the CPU do a bunch of work and then do this big batch and then write it out to the disk and then read me the results. So in the Hadoop ecosystem, a common complaint has been over the last decade and a half or so that we've had Hadoop, the common complaint has been that these batches always take too long. And if you're a data scientist or you're a data preparation person or you're an ETL author and you're trying to work with the data, you get this very like, I'm going to do some work and I'm going to go take a coffee break and then see the results. I'm going to go do some work and then I'm going to twiddle my thumbs and then I'm going to see the results. Because Spark is using memory, you get this very interactive environment where you can load data into memory, you can mess with it, add columns, delete rows, do whatever you want with it. And then at the end of it, you've got a very fast feedback loop. And then when you've got data that you actually care about and you look at it and you think it's valuable, then you could decide to do something with it. You can say, okay, write that out to disk or do something else with it. And that is what Spark is fundamentally. Now, there's a lot of other things that Spark has that have to do with machine learning and deep learning and bunch of different data prep tools that we have. And there are a lot of things that Spark brings to the table, but fundamentally, this is the problem that Spark is solving. It's trying to distribute RAM across those nodes and keep data in RAM so that we can work with it interactively. That's what's happening. Now, the other, we'll talk about some of the other features as the webinar progresses, but I wanted to clarify that, right off the bat. Does that all make sense? I hope that makes sense. Okay. So Spark has some low-level APIs. One's called an RDD, which stands for Resilient Distributed Data Set, and another one's called the Distributed Variable. Now, don't those two things sound like distributed memory to you? That's exactly what they are. Now, those low-level APIs can be difficult to work with, so Spark has some high-level APIs above it, data sets, Dataframes, and a SQL API. The vast majority of your work you'll find will be done in Dataframes and SQL, but some will be done in data sets. And then when you focus on learning Spark, focus most of your time on learning the Dataframes and SQL syntax, because I think you'll feel comfortable with that coming from maybe a relational background or a SQL background, and your ramp up to learning Spark will be a lot easier. And then it has some higher level things above it, like for structured streaming and advanced analytics, like deep learning and machine learning and things like that. And it has a bunch of other libraries and ecosystems to make reading data from different data sources a lot easier. So what applications use Spark? You've heard me talk about machine learning and ETL, and I would say like 85% of the data of the use cases for Spark are in those first two bullet points. And then the remaining are like SQL queries and visualizations and text mining and real-time event processing like IoT and graph applications, pattern recognition, recommendation engines, a lot of analytic use cases. What you're not seeing in Spark is you're not seeing anything related to OLTP. Like if you had to write an e-commerce site and you had to like take individual transactions from people, Spark is not good for writing data and changing data. It is good for data that is in place and to do analysis on data that's additive, but not a single record at a time, right? So you wouldn't use Spark to create Amazon.com, right? We would use a relational engine for that still, or a NoSQL engine for that still. Now, if you want to learn Spark, you can learn Spark in almost any language that you choose. But remember, Spark was written in Scala. So Scala is a functional language that is built on top of Java and runs inside the Java virtual machine, or the JVM. So for a long time, people were interacting with Spark in Scala, and Python became more and more popular in the data engineering and data science world. And Spark created a a Python interface for Spark. And now Python is what's called a first-class citizen. Actually, there are 3 first-class citizens inside the Spark ecosystem: Scala, Python, and SQL. And what that means is that the Spark ecosystem will not create a feature. They will not add anything into the Spark environment that doesn't support Scala, Python, and SQL. So when Spark creates a new version that will be coming out, they come out really regularly. Every single time a new feature is released, it will support those 3 languages. And by default, it will support Java because Scala is built on Java. So Java can be used too, although it's not as popular as Scala and Python. Now, you can also use R, and you can use C#. Microsoft released a Spark C# API 2 months ago, and they're improving on it. So you can, if you are a .NET developer and you want to use C# with Spark, that is totally your decision to make. And then some people are using Clojure, and then I've seen other people attempt to use JavaScript with Spark. I use Python and Scala. And I find that my customers use Python and Scala. And I also use a lot of SQL, a ton of SQL. So, but if you're learning Spark and you want to get up and running quickly, I would say try using SQL, or try using SQL and some Python, and kind of avoid Scala for now, and think of Scala like, as I get to know Spark more and more, try to learn more and more Scala as time goes on. But I think if you focused on SQL and Python, you'd be doing pretty well. Now, Azure Databricks has a lot of built-in connection types to use Azure resources. So in Azure, we can very quickly and easily use Azure Data Lake Store, both Gen 1 and Gen 2. We can use blob storage. We can use Azure SQL Database and Azure SQL Data Warehouse. All the documentation supports this. We can use Cosmos DB, and we can use different messaging systems. Now, there's a lot of other non-Azure resources, obviously, that we can get a hold of. And in this section, I'll show you CSVs and some other files that we can go grab data and manipulate the data from. We already talked about HDFS. It's important to note, though, that HDFS is immutable. Once data goes into HDFS, it stays the way it looks. And then when we write out new files, they're new files. We're not manipulating existing files. And that's an important thing to remember inside Spark also, because our memory objects, like when we create an RDD or we create a data frame, those are similarly immutable, meaning if we change the data frame, we're effectively creating new data frames as time goes on. So when a Spark application is created, I just want to real briefly talk about kind of the life cycle of a Spark application. So a client submits an application here, and that application gets submitted to the driver. The driver gets created for your application, and it looks at your code, and it evaluates what it thinks you're going to do with that code. And what it's really effectively doing is it's recompiling what you wrote to something that it can execute. And when it sees exactly what you're trying to run, it goes to the cluster manager and it asks for resources. And the cluster manager contacts the workers and says, hey, we need dedicated CPU and memory for this application. And the workers create these executors. These executors are dedicated RAM and CPU for your Spark application. And then your Spark application, maybe it distributes across 1 worker or 5 workers or 10 workers. And then the driver submits the code, the application that needs to run to each executor. The executors execute that. They get the results that they're looking for, and then they hand those results back to the driver, and then the driver hands the results back to the client. And then the driver and the executors go away. That they're only in memory for as long as the application needs to run, and that's it. Now, you as the client, you are hidden from the complexity of that. All you're doing is writing code. You're saying like, change this string to an integer, or delete these records, or filter out this, or summarize that, or aggregate this, or group by this, or whatever you're doing, map this, right? You're just like submitting commands as if it's one logical data set, and it's hidden the fact that they distributed this across a whole bunch of nodes for you. So just remember that part. Also remember that all of these components run inside a JVM. Spark is written in Scala. Scala runs inside a JVM. So when we go back to this slide and we see all these different nodes, don't get confused. These might not be separate servers. They are just JVMs. So you can have a bunch of JVMs run on one physical machine. This is how we get Spark to run locally on a laptop. Now, if you want to learn Spark, you can configure Spark on your laptop with, you know, whatever, all the components that are necessary to learn it. It takes a little bit of time to do that. Or if I were you and I wanted to learn it, I would just go into my Azure portal, and let me just show you that real quick. So I'm going to bring here. Let's go to portal.azure.com. Okay, my portal comes up, and this is really easy. Just click this green Create a Resource button. I'm assuming you guys have Azure already. If you don't have Azure, by the way, you can just go to the Azure free trial and sign up here. You'll get a big free trial where you can start using Databricks right now. This $200 credit, don't worry about it. You can use an awful lot of Databricks and Spark for $200. You could use it all month long and probably not spend $200 as long as you keep your node count low, and I'll show you how to do that in just a second. So sign up for the Azure free trial. That's one way of doing it. Another way of doing it, if you don't want to use Azure, you don't have Azure, is you can go to the Databricks website and look at their community edition. If you sign up for their community edition, they don't charge you. They give you access to a Databricks cluster and sample data sets, and they have all kinds of Databricks tutorials that you can run through and learn about it for free. So the point is, you can start playing around with Databricks without the complexity of putting Spark on your laptop, and it won't charge you. You can do this for free, okay? So I'm gonna go back here, and I'm gonna just type in Databricks into Azure, because we're gonna assume that you have an Azure account, that you can go into the Azure portal, that you can say, hey, I want a new Databricks workspace. So you see Azure Databricks here. After typing it in, you click on that, and it says a little bit about it, and you click Create. Now, here I'll just call this Wintellect Demo. So that's my workspace name. And it asks for a resource group. Now, resource groups in Azure are a way for us to add a bunch of resources to a resource group. And then when we're done playing around with it, if we delete the resource group, it deletes everything inside of it. So resource groups are a great way of organizing the things you create so you can clean up after yourself when you're done. Or if you don't want to clean after yourself, and you want to use it extensively, let's say that for Databricks, you need Azure Data Lake Gen 2, or you need a SQL database, or you need a bunch of files or whatever, you can put all that stuff in a resource group, and now it's logically organized for you so you can find it later. So I'm just going to create a new one, keep it in West US, and then for pricing tier, right here, I can go to trial, which is a premium version of Databricks, 14 days free. Perfect. That's perfect for learning. Okay, so I go ahead and click create. Now, this question right here, do you see this? That question said, create Databricks in your own virtual network. That is an important question. So right now, it's creating that workspace. Let me talk to you about that virtual network in Azure, because you're going to want to know what's going on there, particularly if you're a consultant. I don't know if any of you are a consultant, but if you have an enterprise network, so this is corporate network, right? And this is Azure. I created Databricks, this is Databricks right here, over the public internet. So right now, if I'm interacting with Databricks, it's going to go over SSL, so that's encrypted, but it's definitely going to go over the internet. So I can create a direct connection through to Azure by one of two ways. I can either use a virtual network, or I can use ExpressRoute. What that does is it creates, the virtual network goes over the internet also, but it encrypts the whole pipe, more so than just SSL. All communication is done through the virtual network. ExpressRoute is a private network off the internet. So the data can move on like an MPLS line or some other line directly to Azure. So you can create Databricks instead of on the public internet, you can create it on this private pipe and secure it. And that, so if you need to answer a security question or auditor, or just you have corporate IT policies that say no data goes over the internet, you have that option available to you. Okay, hopefully I've talked enough and Databricks is up and running. Now, if I click on all resources right here, and I go look for that Wintellect thing at the bottom, here's Wintellect Demo. And you can see this is a Databricks environment, and right here it says Launch Workspace. And if I click Launch Workspace, this Databricks environment that's coming up is not unique to Azure. This interface that you're seeing is the interface that you would see in AWS, and it's the interface that you would see if you used Databricks directly. And this is a Spark workspace that allows me to create a notebook and run code on a cluster. Sometimes this takes a little while to log in the first time. I don't know why that is. Let me just hit refresh real quick and see if I can jumpstart that. If I can't, then rather than wait the time, we'll just use a Databricks environment that I've already created. Okay, why don't we come back to this and I'll just show you an environment that I already have. So I'll come back here, and if I go by type, resource type, oh, there we go. Here's my Ike Databricks environment. I'll launch this workspace and it will come up much faster. Come on, there we go. Okay, so this environment right here is broken down into several things. It can be a little daunting when you see this at first, but I want you to learn one thing right away, and that is if I click here and click New Notebook, I can name my notebook Wintellect Demo. I can choose my language, right? Look, we already talked about Python, Scala, SQL, R, right? I'm going to choose Python. And then the cluster I'm going to run is a cluster that I've already created called the Ike cluster, and I'm going to click Create. There we go. Now I can start typing code here immediately, and it will immediately start working. Let me just show you some basic code that you might want to type when you start your notebook. And that is, I'm just going to read data from a CSV. This WASB is an Azure Blob Storage account. This is my Azure Blob Storage account. This is the file, the CSV that I want to read. The header is the first row, and I want it to infer schema, and then I want to show some of the results. So when I click play and I run this cell, it submits that immediately to the Spark cluster that's running, this Ike cluster 4. It read the CSV into memory, that distributed memory that we talked about earlier, and then it showed it to us immediately. And you can see this right here, right? That's not difficult code to write. You could have written that code, right? Now, a couple of things about it. Let's click down here to clusters. I already had a cluster running, this Ike cluster 4, and it just used that Ike cluster 4 immediately. But that doesn't have to be that way. I can stop this cluster, and if I terminate this cluster, I stop paying for Databricks. You can see right here, there's a terminate after 120 minutes of inactivity. So if this cluster ever pauses and isn't running, 2 hours later, it turns off. It takes about 5 minutes to turn it back on, so I'm not going to turn it off right now. But that is a very valuable thing to control cost and money that we're spending. Basically, if we're using it, keep running, and if you stop using it, turn it off. I could create all kinds of clusters. Look at this. So if I say create a cluster, this is my Wintellect test cluster, right? What mode do I want it in? Standard is fine. What Python version do I want? Do I want to enable auto scaling? So this says start me with 2 workers. Remember, we talked about workers before. When the driver asked the cluster manager for resources, it went to the workers to create the executors, right? I could say start with 2 nodes, right? And go to a max of 8 nodes. Or if I clear auto scaling, and if you're just learning Spark, I would recommend doing this. You could say, I just want 1 node here. And then you get to pick the size of node you want. Do you want 14 gigs of memory, 28 gigs of memory, 56 gigs of memory? And of course, the number of cores are going to scale up, as that happens. For us, we just need 14 gigs of memory. That's fine. We're going to use the cheap version. And if I click create cluster, now this cluster is going to get created right here in just a little bit. So there it is, Wintellect test cluster. It's pending. It's going to come up. Now, here's the beauty of the Spark workspace. If I go back to my workspace and I go back to that Wintellect demo with that 1 line of code there, you can see that I get to choose which cluster I'm running against, which means that my code and the actual physical execution of the code are separate from each other. And I'm going to repeat that. My code and the cluster are separate from each other. So my code is being stored in this notebook in the Databricks workspace, and the clusters can turn on, they can turn off, they can change. They can be 4 nodes or 10 nodes or 20 nodes, whatever, right? And the cool part about this is I can have so much code here, right? I can create all kinds of code here. Like let's add a cell below, right? Now I've got code coming down here all the time, right? Bunch of code. And I can turn these clusters off. And if a new Spark version gets released, like instead of Spark 2.4.1, we want Spark 2.5, we can just create a 2.5 cluster in 5 minutes, and we can be running this code on a 2.5 cluster. So that's an awful lot different than like a SQL database, right? In SQL Server, if you have SQL 2016 and you have 1,000 stored procedures in 2016, and you want to migrate SQL 2016 to 2019, those stored procedures migrate with it, right? All the data and all the code and everything is self-contained. And when you upgrade it, it's like this long, arduous process. But what I'm showing you is that in a Spark ecosystem, the data is external, the code is external, and the clusters are kind of like their own independent thing. So they can be managed, turned on, turned off, upgraded, changed, independent of the code and the data. And that's an enormously powerful thing in this ecosystem. Really flexible. Okay, so let's go back to our clusters and see if that thing is up and running. No, it's still kind of coming up and running. Let's go back to my Ike cluster 4. And if you can click on this, you can see like all kinds of different things that are happening with this. Like if I click on notebooks, you can see that my Wintellect demo notebook is attached to it. Okay, so I'll go back and click on Wintellect notebook. Okay, now this simple thing, if I increase this, you can see that a Spark job got created. And that Spark job actually performed real work for us. So if I click view, what you're seeing here in this Spark job is what is called a DAG. And this DAG is the key to understanding how Spark work gets accomplished. And I want to simplify this DAG for you. So let's go back to the slides real quick. Boop, 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 here. The DAG. Okay. Those of you with a relational database background know that when you submit a SQL statement to a SQL engine, it goes to an optimizer, and the optimizer compiles that statement into something that's executable, and then it caches that compiled statement, right? Well, Spark is doing something similar to what SQL does. It looks at your work, and it takes a look at every piece of code that you want to write, and it creates an executable version of what your code is. And that executable version, the plan that it's going to use when it executes, is called the DAG, which means that what actually gets executed could be different than the code that you're actually writing. And that is an important distinction, that there's a disconnect between the code you write and what gets executed. There's a little bit more nuance here too. When you write code, let's go back to Paint. You've got code. This is all Python code, let's say, right? Spark separates your code into one of two types, either a transformation, or an action. So a transformation is you saying, I'm intending something to change. I intend. And then an action is, I am doing something. This is something real. This is me using data. So it's important to note when you see Spark code, what a transformation is and what an action is, because it will help you understand the DAG. So let me give you a little bit more complicated Python code that will help you see this. So if I go back to our Wintellect demo, right? And I go to boom, here, okay. So here I'm adding a column called count, and I'm adding a literal called 1. And then I'm creating a new object here in memory. This is a data frame, and I'm creating it off of my original airports data frame that I created up here, right? And then I'm doing some things with it. You guys know this, filter, right? That's like a where clause, group by, sum. If you know SQL at all, you're familiar with this. This is me renaming the column. I'm renaming the count to total, right? And then I'm sorting it, and then I'm showing it. Okay, what's happening? Transformation, 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 transformation. This is all me saying I'm changing something. I intend to change something. And then show, that's the action. Show is do some real work right now. So if I run this code and it submits it, and now you can see that it filtered it with every airport that had an altitude greater than 1,000 and filter and group by destination, and then show it to me. And these are all group by destination, how many airports I have, right? So if we look at the Spark job, you're going to see a much more complicated DAG. And it says, okay, I did this, and then I did this, and then I did this, and then boom, I finished, right? Okay. Spark is doing something kind of magical here. It's like black magic, and it is called lazy evaluation. Spark delays execution of your code until an action is actually called, like collect or write or show. This allows Spark to delay the creation and execution of the DAG until it sees how the code is being used. For instance, it might have a more optimal way to execute something if it sees that the action is give me the max record or give me a count of all the records. That DAG is then managed across all the executors by the driver, meaning it's delivered by the driver to the executors to tell them exactly what to do. So all statements before the action are just parsed and they are not executed until Spark sees an action. And for new Spark developers, this is a very scary thing because what they could see here, these could all be individual lines of code, right? I could easily rewrite this if I came down here, boop, 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 as I could say like, this is airports.filter. This is one line of code. And then I could say down here, the same kind of code right here, right? I could say this is a group by, and then same thing right here, right? This is a sum. Now this won't execute exactly this way, but for new Spark developers, they could say, oh my goodness, I'm getting all the records back. And then once I have all the records, then I'm grouping. And then once I group, then I'm summing. This is a very scary thing. I don't want to do that. And so when new Spark developers go through the tutorials, if they have any relational experience, they're like, oh my, I don't want to do this. I'm going to go into a terabyte database and request all the data. I'm going to run out of memory. I'm going to like load the source system and the source system is going to choke on me, right? And then they just bail out of Spark and they quit, right? Because they're afraid of what they're doing. And it's because that they don't understand this fundamental thing that's going on. They don't understand lazy evaluation. No, Spark is not getting all the data. Spark is not grouping before it does the aggregation. Spark is waiting. Spark is parsing and it's waiting until it sees the use. And then once it sees the use, it will push down the right predicates to the source system. So it only gets the data that it's looking for and it manipulates it in the most efficient way it possibly can. Now, we can criticize Spark. Maybe Spark isn't the most efficient we can think of. Maybe Spark isn't pushing down the way we would hope it would push down. Maybe it's not smart enough, but this is why Spark is revving. Spark is getting better and better at every version to make that push down execution and that lazy evaluation faster and more efficient and better for your code. So it's a critical thing to know about Spark, and I hope this has simplified something that a lot of people get confused at right at the very beginning. Okay, so we talked about transformations and actions. What else can we talk about that might be important to note? Here's a few, let's just kind of go down some code and then we'll talk about what's happening in that code kind of line by line. I think that might be a better thing to do. Okay, so I'm going to delete all of this because we don't need it. We'll go back to the way I originally wrote the code. And then let's take a look at something. So this airport's, just to level set again, this read a CSV and then it showed you data from the CSV. Then down here, we created this airport's high altitude, and this table just had 3 rows in it. Now, we might say, I want to do some more manipulation with this airport high altitude, right? And so what we can do is we can write code that looks like this. We can say, take airports high altitude. Let's take that variable right now. And let's create or replace a view. And we'll call that airports high alt. Okay. So I think that code should run. Let's run that cell. Oh, let's see. Airports high alt, create or replace temp view. Didn't I name that correctly? Oh, there it is. Yep. And let's run that. And no, that is a, didn't this run? I thought I ran this. This is a data frame, right? Let's do it from the airport's data frame because that should work. Let's call this true airports. There we go. Okay. So now that we have this temporary view, true airports, this allows us to interact with this using SQL. And SQL can be a very easy, much easier way of interacting with Spark than using Python. So if you know SQL already, then you can read code that looks like this. And that is, hey, from that true airports, let's throw that there, select every record, give me 10, right? So just standard ANSI SQL. And then once we take this SQL and save it off into a query, we can call spark.sql on the query and load another variable, and then we can show that variable. So let's run that, and we'll run that cell. And now you can see just 10 records coming out of airports because of the limit 10. And now we can begin to use SQL to interact with our objects. So this create or replace temp view is what allowed SQL to be executed against it. Now, you saw me do a filter here, right? We can also do a filter here, right? We can say where FAA equals 04G, or we can, implement any kind of where clause that we want here. But the point is, SQL is fully implemented inside Spark. So if you feel really comfortable with SQL, you can do all sorts of things. Like some of you who might have SQL experience might be comfortable with code like this, right? Describe, we'll do the one we just created, true airports, right? So if I say, hey, describe true airports and show me what it looks like, oh, look, here are all the columns, here's the data types, here's whether or not they're nullable or not, right? So we've seen describe before in other database systems like Postgres or SQL Server, and that absolutely works here. And it might surprise you to know that if you're really comfortable with SQL, you can actually do things like this. So I am going to just show you this code and not run it, because we don't have time. So look at, what is this? Have you guys seen this before in SQL? What is this? These are windowing functions. So this is how mature the SQL ecosystem is in the Spark world. So you can take this, you can execute that query, you can load a variable, and then you can do something with it. Like you can write it out to disk if you want to write the results out, or you can show it to people, right? So code like this absolutely does work. In fact, if we wanted this code to work, we just have to go load that retail data above it. So this data, again, this is me CSV reading a CSV, getting the header out, inferring the schema, storing it to a variable. Then I'm changing some columns, right? Then I'm showing it. I can take that show out because we don't need it. I can even save it as a table, and I'll explain that code in just a second. And then, in fact, let me comment that code out right now, and I'll come back to that. And then I can query it, and then I can show the results. Let's see if that runs. Boom. And here's the result. That's that CSV getting run. And then this is the window function being executed over it. And then my results coming back. We're kind of running out of time, so I don't want to spend a lot of time discussing exactly how window functions work, but I just wanted to show you that you have a very full-featured SQL interface with this data. And if you'd like, you can you can save it. So that brings us back to this code here that I commented out. So this code allows me to save my results as a table and then interact with that as a table. Now, the difference is you saw me use SQL on a temporary view. When this session is over, that view goes away and the data goes away with it. When this table is created, that table gets created in a catalog that I can interact with at any time. And when the session is over, the schema and the data get preserved. So if I click on data over here in my Spark workspace, you can see that I look at full retail data, right? And I click on it and you can see my columns, right? You can see a sample of the data coming out, right? That got saved in a catalog for reuse. So it's a very powerful thing that we can do inside Spark. Now, with the remaining time, I want to talk a little bit more about the programming interfaces that I've kind of glanced over. The most important thing that you can learn about in Spark is that when you have this shared memory, you are using something called an RDD, or Resilient Distributed Data Set. That's that memory mechanism that's stored across all of the workers and the executors, so that it is interacting like it's one logical set of memory for you. So if I go back to my code real quick, when I'm reading this data in, right, is there anything in this code to say how many nodes I'm using? Do you see me anywhere in here say, hey, you're using 4 nodes, or you're using 8 nodes, or 10 nodes? No, that is abstracted from me. So the Spark cluster is determining that for me, depending on what data I'm reading. So what's happening here in an RDD is you've got distributed memory for use across multiple nodes, but the developer never needs to know that. It's abstracted from the developer. So those RDDs are somewhat difficult to work with. And so what you've been seeing me do here, let me bring up this slide, is you've seen me interact with the RDDs using a data frame. And so all of the code that you've seen me write so far has been data frame code. And what a data frame is it's just a Python abstraction of the RDD that's underneath it. So as you've seen this code right here, like retail data, that's a data frame, which effectively is a Python abstraction above the RDD. So that I don't have to interact with the RDD directly. Let me just kind of make that clear for you, just with one other set of code here that I think you'll find interesting. So this, let me open the new code. Okay, I'm bringing in flight CSV, and I'm reading flight CSV into a flights object, and then I'm showing you the type. So do you see how this type is an RDD? Okay. Now in this line of code, I just wanted to show you what the data looks like to me if I interact with the RDD directly. So does that look fun to you? That's very difficult to read and work with. It's not tabular or columnar. It's just the data as it's being distributed across multiple nodes, right? So if we take this line of code that showed you that it was an RDD, print type flights, right? And here we do that for full retail. So we say, show me what full retail is, and we execute that. Go quick. And it says that is a data frame. And so here, when we want to see what that looks like, we just do full retail.show. And now you're seeing what? Columns and rows. You're seeing tabular data, right? So you can see by comparing the data frame to the RDD, when we go back to the slide, that's why we have a need for a data frame, because that Python abstraction makes the data look more like Python and other data professionals expect it to look. They expect tabular data. They expect to be able to add a column. They expect to be able to rename things. They expect to be able to change data types. All of those operations inside the underlying RDD it's more difficult. So we're still using an RDD underneath. It's still the fundamental way of distributing data across executors in Spark. We're just making it much easier for the Python developer to consume it. And just FYI, PySpark was basically written with the same design ideas as pandas. And pandas is a very easy framework that Python developers have been using for a really long time. And so Python developers who know pandas have a very easy time migrating over to PySpark and interacting with Dataframes. They understand kind of what's going on there a little bit easier. Okay, so you saw me read a file in. That's adding a column. You can easily add columns. That's saving tables, which we already talked about. We can list all the tables, by the way. So let's talk about that. Let's see what so if I say print spark.catalog.listTables, and we go take a look at it. It's going to come back a little bit ugly, by the way, but it does come back. So look, flights with airports is one of my tables. That's a managed table. Full airports, that's a managed table. Now, if we go look for the one kind of temporary one that we created, which was what? We said that is managed. We called it true airports, right? You guys see it? How am I not seeing it? Usually it's right here. Full airports V2. Full retail data. I bet one of you guys is seeing it and you're just frustrated you can't tell me. I don't see it here, but oh, temporary table, there we go. So, oh, that's true airports right here at the bottom. There it is. And table type temporary right here at the bottom. So you can see that these other table types are the persistent kind that I told you about earlier, and then true airports is temporary. Once the session's over, that thing's gonna go away. We already talked. So this code kind of makes more sense. What we're doing here is creating a query. We're interacting with the airports table, and then we're creating a data frame, and then we can add columns or change data types or do all the things that we would want to do in an ETL pipeline inside the data frame before we write it out to disk. We can also do an explain plan here. And so let's take a look at what that code looks like. So if we come back up here, and we have this like complicated thing, right? And you see that the Spark SQL is going to execute it, right? Instead of the SQL executing it, we can say, just explain it. And let's get rid of that show. Excuse me. And now let's run this again. Uh-oh. Oh, we don't need that code. I meant to comment that out. Get rid of that. Okay, so now with explain plan, we're getting more insight into how Spark is actually going to execute this and hand the results back to you. And by the way, not only do we have that, but if we take the explain plan off and then we do full retail.show again, so we've got the explain plan, but remember, we can always run the exact thing and then take a look at the jobs and then take a look from the jobs, take a look at the DAG, and using explain plan and the DAG and the Spark logs, we can really get a handle on lazy evaluation and execution and push down execution and really understand exactly what Spark is doing and how it's interacting with the data and how it's performing across those multiple nodes. So I think my hour is over. Hopefully you learned a lot in this hour, and hopefully this didn't seem that complicated to you. I wanted to kind of demystify this. This code, like, do you feel like you could not write this code? If you're a SQL professional, I firmly believe that you can use your SQL skills and interact with Spark and create tables and filter and group by and change, and then write it out to another file or write it out to a SQL database or wherever you want to consume it, or put it into a file and have Power BI ingest that file and interact with it. I think it would all work. So with that said, we've got a few minutes, and I'm just going to go ahead and quickly take a look at the questions and see if there are any answered questions. Somebody said the slide deck is not changing. Is that true?
No, it was fine.
It was fine? Okay.
Yeah.
All right. It looks like that's only seeing one page of the slide deck, not changing. Uh-oh. Sorry about that. I didn't know that. Anything else? No questions. Well, I'm like giving people a chance to type. Look, if you guys want to get a hold of me or you're interested in more that I have to offer, by the way, while I do that, this is me. I'm Ike Ellis. And like I said, I'm an MVP. I've written books. I've done a whole bunch of things for Wintellect and will continue to do so. And I'm on Twitter at Ike_Ellis. So feel free to follow me. I make a lot of YouTube videos, a lot. And I make them on Power BI and Databricks and SQL Server and Excel and a whole bunch of other data related topics. So if you're a Microsoft data professional, you want to check out my YouTube channel, it's just Ike Ellis Data. If you go to ikeellis.com, all my links are there if you're interested. And I'm not seeing any other questions, so I think that's it.
There are a couple of them, by the way.
Oh, you see them, I don't see them.
I do. It says your example covers .cvs. What about real databases and how it's read?
Oh, that's a good question. So it's, hang on, let me bring up. So we can absolutely use any data source. I didn't show you bringing data in from Azure SQL Database, but I'm releasing some videos on pulling data from Azure SQL Database and Azure Cosmos DB right now. So if you check my channel, you'll see how to do that. You will find that Spark professionals tend to prefer working with flat files because they are faster. And I know that sounds crazy to people who are used to relational databases, but let's talk about what is happening with a relational database. The relational databases are not built for raw speed. They're actually built for concurrency, meaning they are built so that thousands of people can get to the data without them affecting one another. So they have all of this overhead related to locking and blocking and indexing to make reading and writing the data as fast as possible, assuming that there are thousands of people on it. In most Spark ecosystems, there are not thousands of people on it. Often there's only a couple of people, or maybe a few data feeds, or maybe a couple of data scientists, maybe 30 people. And so all the overhead that's necessary for thousands of people, it actually can be slow in like single pass write or read scenarios. So you'll see in Spark, they'll ingest data and then they'll write it out. And then maybe they'll write it to where they'll consume it. Any other questions?
Yep. There is, how about some resources that you could recommend for learning Spark and data science on Azure?
I promised you that I would tell you that.
Yep,
Okay.
and the future trends.
Yeah, that's a good question. So if we go, can you see my screen still?
Yep.
Okay. So right now, I recommend this book, The Spark, The Definitive Guide. I know it only has 3.5 stars, but I think it's a great book, and it will introduce you to Spark streaming, Spark batch, a lot of Python and Scala, and deep learning. A lot of you might not know Python though. And so if you just want an introductory level to Python, DataCamp has some courses here that give, DataCamp is not good for advanced topics, like topics that Wintellect would teach, but DataCamp is really good for very beginning introductory things to kind of get you familiar with Python. I think that you can get pretty far with Spark using the SQL interface, but you're eventually going to hit a wall and you're going to want to switch to Python. So if you don't know Python, you're going to want to learn it. And then this book, and then I actually do think that the docs are really effective. So if you're using Azure Databricks though, make sure you use the Azure Databricks docs. They look the same, excuse me, Azure Databricks docs. So these docs look the same as the regular Databricks docs, but there's some Azure specific content that is very valuable in there. And they have all kinds of tutorials and walkthroughs here that are very useful. And then, of course, Wintellect courses and up and coming courses that we're going to be offering.
Okay, a couple more questions.
Okay.
Can we read data from HBase or SOLR and create a data frame?
You can from HBase. I'm not sure about SOLR, Solar. I think so, but I haven't done it. I'm 90% sure you can, but I haven't done it. But definitely from HBase.
Okay. How do you automate notebook code in production?
That is a great question, and I'm glad you asked that. So
Thank you,
one of the
Derek.
things, yeah. So let's say this code, right? Now, this code's got a bunch of stuff in it that you wouldn't want, like this show, right? Like you wouldn't want that show in your code, right? Typically what you would be doing here is you'd be like reading something, you'd be changing it somehow, and then you'd be writing it out, right? That would be, so first thing you do is you clean it up, get rid of the stuff that you don't think you're gonna need, right? Then you would add logging to it. And in the Spark ecosystem, we use Log4j. And I actually am releasing a video real quickly. Like I already wrote it. The video is right here. I just need to publish it on implementing Log4j and Spark notebooks. And then once you've done that, you just schedule it. And when you click schedule, you just click new here, specify, how often you want this thing to run. This is one way to do it. Here's another way. You can click on jobs, right? Here's a job that I already created, but you can just click create job. And then you could say, okay, was it Derek? Who asked that
Yes, it
question?
was Derek. Yep.
Yeah, Derek's question, right? So we could say, okay, from here, run that Wintellect demo notebook. That's the one we want. And then it says, oh, what cluster? I can say, oh, I want a new cluster. Or I can say, run on an existing cluster if I wanted, right? So do an existing cluster, right? Maybe I make it that Wintellect test cluster that I created earlier, right? Then I schedule it, click edit, right? Then once I have that scheduled and it's running every hour or every day or whatever, then once it runs, I get logs. So if I go back here, by the way, to that one I already created and I click on it, you can see that I can go look at the logs and I can see exactly how that thing is running over time, right? So this is, what is slow, what's fast, what took too long, what did the results look like? Those would all be present in the driver logs for that job. Remember, the Spark driver is that entity that created all the resources and was in charge of running my application. So that driver log, you can see exactly what the driver did, right? Including seeing the DAG of anything that it went and created, which is very powerful. Okay, any other questions?
Yep. A couple more. What's the point of using Spark when you have a database that is less than 100 gigabytes or so? Can I just query it directly?
Well, the point is not that you know the data, it's that you can't predict the data in the future. So if you were going to create a huge ETL application, right? And you're like, oh, I've got 20 files that I have to import every night. And I know that it's a gig of data. And so I use SSIS. Fine, use SSIS. It'll probably work just fine, right? The problem is when you don't know how large it will eventually be. So if you're in a high growth organization and you're trying to ingest data into a database, and it's a gig now, but it might be 10 gig, there's a point where you know SSIS will be fragile and will have trouble scaling, right? If you already have questions about the growth right now, then use Spark, but only use it on, a one node cluster, right? A one worker cluster. And then as you scale, you can scale it up with, there's some effort. I don't want to say no effort, but with a lot less effort than it would take to scale up another ETL package.
Okay.
Oh, and you get to pick your scale at execution. So your level of scale is now independent of the code you wrote. So you can say, hey, run it on 4 nodes, run it on 8 nodes. That you don't have to rewrite everything as you scale and parallelize things. Because remember, lazy evaluation and lazy execution and push down execution allows for the developer to be disconnected from the actual implementation of what's executing.
Okay. I think you might have already answered this one, but any tutorial that you recommend for beginners?
Yeah, I did. I
Okay,
answered.
so that's the data camp. Okay, what's your thought about the new Spark features coming in SQL 19?
So the big data clusters, yeah, that's an interesting thing. Now, I'm going to speak frankly on this, and Microsoft might not like it that I'm speaking frankly about it, but um, I'm going to do my best because I love Microsoft and I love the team that did this. They're doing great work. The Spark clusters inside SQL Server they don't scale. It's not like a huge Spark ecosystem. It's just basically its own JVM and driver inside SQL Server. And that is a little concerning to me because SQL Server charges on per core licensing, and um, you're basically loading the thing that you're paying for, right? You don't want to, if you load it too much, you're going to have more cores, and that's going to be a lot more expensive. You know, it's $6,800 a core right now, right? So in limited use cases, it's very effective because what it does is Spark has all kinds of different libraries and packages built around deep learning. And so if you have a ton of SQL data and you want to use all of the Spark resources close to the data without moving over the network, then it's a great tool and resource. But I wouldn't consider it your Spark scale out ecosystem because Databricks is a lot cheaper than SQL Server. Like I would do that outside of SQL Server and just take the network hit, move it into a data lake, and then interact with it in the data lake. As a long-term like enterprise data architecture, that's what I would do.
Okay. How do you use Databricks Notebook as a part of Data Factory?
That is a great question, and I don't have a demo prepared for that right now, but I'm going to add that to my list of videos to make. So look at Twitter and my YouTube channel, and I'll release a video on that. It's not that difficult, and I'll show you how to do that in a later video.
Okay. And Joel wants you, good to call out the ADF data flows run on Databricks under the covers.
Yeah, so he's helping me with my lecture, and that's totally fine. Azure
Uh-huh.
Data Factory is Databricks. It is the Databricks ecosystem. It's just a GUI sugar over it to make it easier for you, but it is built over Databricks. And AWS has a similar product called AWS Glue, and that is also built on Databricks. So even these big cloud vendors are building their ETL frameworks and their orchestration frameworks over Databricks. That's how popular it is. Somebody asked me about the Databricks future, and I think it has a very bright future. So it is the most active open source project in the world today under the Apache license. 400 companies are committing work to it. They're paying their employees to commit work to the Spark project. So Spark has got a tremendous future.
Okay. What's the strategy if you need transactions and access to big data? Would it be the same data solutions or would it be Spark plus SQL? To elaborate, let's say you need to find some insights on data that comes for multi-user solutions.
I would stage it first then, and I would control so you're asking for several different things, right? If you need insights on current changing data, that strikes me as an alerting system, which means you'll be streaming and alerting that. But if you're doing hardcore analytics, then having the data change out from underneath you too often is not stable or maintainable. So I would either use streaming and eventing to do the alerting analytics, or I would do staging and batching to do long-term analytics. And you can learn more about that. It's called the Lambda architecture, a Lambda data architecture. I don't mean to be condescending, by the way, but just in case you haven't seen this before, it's speed layer for alerting, batch layer for long-term analytics, as opposed to like, constantly worrying about locking and blocking in transactions. The overhead of the transactions, it's too much to manage, and it really, really slows down the system. So I would avoid doing something like that.
And that was your last question.
All right, you guys, thanks for sticking with me. I hope you guys learned a lot, and I hope we achieved our goal, that this made this a lot simpler and more accessible for you to learn in the future. Thanks, guys. Have a great day.